Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into a truly mind-bending concept, emulating a GPU on a CPU using finite field assembly. Get ready for some serious math, folks.
Whoa, hold on a second. Emulating a GPU on a CPU? Isn't that impossible? I mean, GPUs are built for parallel processing, right?
That's the conventional wisdom, yes. But this article proposes a radical alternative. Forget about traditional parallelization and vectorization. Instead, let's invent some new math.
Invent new math? Are you serious? This sounds like something out of a science fiction novel.
That's the beauty of it. The article introduces finite field assembly, FFASM, a language built on the idea that much of math is invented, not discovered. They use finite fields and recursive computing, a calculation within a calculation within another calculation, to achieve parallel computation without SIMD or OpenMP.
Recursive computing. So instead of many threads running concurrently, you're nesting calculations? That's intriguing, but how does it work in practice?
Well, they provide a couple of examples. First, a Hello World program that sets up an 8-bit unsigned integer finite field. It uses the GNU MP Bignum library, which, you'll need to install. Then, they show how to perform addition and multiplication using these custom finite fields.
So you're essentially creating a custom mathematical system tailored to the problem? That's a very different approach to parallel processing. I see.
Exactly. And the code examples are surprisingly straightforward once you wrap your head around the underlying math. They use functions like !FFASM, malloc !FFASM, set field order !FFASM, append data !FFASMADD and !FF_ASM multiply to manage the finite field and perform operations within it.
But wouldn't this approach be incredibly slow compared to a real GPU? I mean, the overhead of all this custom math must be significant, right?
That's a valid concern. The article doesn't benchmark performance against a GPU, which is a major omission. However, the core idea is fascinating. It opens up the possibility of exploring unconventional approaches to parallel computation. It's like, rethinking the fundamentals.
It's certainly a bold claim. I'd be interested to see some performance comparisons. But the conceptual innovation is undeniable. The TORFs. It's a completely different way of thinking about parallel processing.
Absolutely. And the project is open source, so anyone can contribute and experiment. They're also working on extending the functionality to include subtraction, division, support for different data types, and even a polynomial arithmetic library. Ambitious, to say the least.
This is a really interesting exploration of the boundaries of computation. It shows that there's still a lot of room for innovation, even in seemingly well-trodden areas like parallel processing. It's inspiring, actually.
Indeed. And it highlights the power of thinking outside the box, or, in this case, outside the traditional mathematical framework. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the fascinating world of finite field assembly. Until next time, goodbye.
Bye-bye.